Okay, so now here we go. We're back in test number 2. We're addressing the periodic table. First one was by Dmitri Mendeleev. It's been modified several times, but remember the key are the periodic trends that occur. So let's talk a little bit about the periodic table itself. So you may have had some of these. Some of these may be a little bit different than you've learned, because what we're learning is, remember in college, and I say this all the time, but I'm teaching you to think like a chemist. I'm not teaching you to think like a high school, in a high school class. It's good, but we want to teach you in a high school class to know some basics so you can think like all kinds of scientists, because you don't know what you're going to be. But in chemistry, in college chemistry, we got to teach you to think like a chemist. Okay? So you may hear different words here. I'm going to show you some things that are important to a chemist, some things that are not important to a chemist. All right? But here are the names of the different, remember, groups run from top to bottom. Group 1 are the alkali metals. Group 1, okay, is the alkali metals. So what's in that? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So you see what I mean? Everything in group 1, okay, are the alkali metals. Everything in group 2 are called the alkaline earth metals. Okay, once again, beryllium, magnesium, calcium, strontium, barium, and radium. Now, let me say this, and this is really important. We're talking about thinking like a chemist. We don't ever make you memorize the periodic table. The periodic table is always a given. That's why we'll say on a test, be sure to get a copy of that periodic table before you take it. Especially with online, we're not there to hand you a copy. Be sure you print off a copy of the periodic table. Make sure it doesn't have any other writing. I mean, that'd be cheating. But the periodic table is a given. Chemists never say you got to memorize a periodic table. I use carbon so much that I know that the mass number for carbon is 12. I know it's for bonding size. But you don't memorize the periodic table. It's a given. Okay? Anything on the periodic. So what's given on the periodic table? The group it's in, the period it's in, the atomic number, and the mass number. That's given on every periodic table. And that's another reason why we like this particular periodic table. It doesn't have a bunch of different colors. It doesn't have the boiling point, the melting point. It doesn't have all these things. We don't want all those. We can Google those. Okay? We need the element that's on there. Okay? It's kind of nice to know if it's a solid, liquid, or a gas. Solids on here are black. Okay? Gases are red, and liquids are blue. Wow, look, francium's a liquid. That creates all kinds of issues. So, and then the clear ones we mentioned in the last video, those are synthetic or man-made. So as we look at this, okay, group 1 was the alkali metals, group 2 was the alkaline earth metals. Now, groups 3 through 12 are all right in the middle here. Those are called the transition metals. Those are transition metals. And we'll talk about all of these as we go. Okay, group 18, we're going to skip all the way over here. Group 18 are the noble gases. Now, why are they called noble gases? They're called noble gases because they don't bond with anything. Noble gases absolutely don't bond with anything. Why is that? Because they already have the octet rule. There's 8 valence electrons, except in the condition of helium that has 2 valence electrons, and there are 2 s2s, it's full. Because what? We need s2, we need p6. But if we need s's and p's together, then we need 8. That's the octet rule. So these don't bond with anything. Why are they called noble gases? Because especially back in earlier times when the periodic table was being named, if you were a king or a queen, you would have a son or a daughter that's a prince or a princess. Well, they were called nobility. They were noble people. It was kind of a bad deal. You're like, oh man, I wish I was a princess. I wish I was a prince. That was tough. Because the prince and the princess could only associate with other nobility. You couldn't associate with common people, let alone marry somebody that's not nobility. So if somebody was the king of England, okay, and they had a son and he was a prince, or a daughter and she was a princess, then they had to marry nobility of someone else around the world, or a lot of times they had prearranged marriages. It was kind of bad, but they could never marry somebody that wasn't noble. That's why Princess Diana was such a big thing in Britain, because who was it? Was it Prince Charles? I lose track of all those things. Okay. So anyway, they came in and she said he fell in love with Princess Diana at college, and he married her, and she became, she became nobility, but she was not, she was just a normal person. Okay. So when they say noble gases, they mean they don't hang around with anybody. Okay. All right? Noble means they don't bond with anybody. They only thing they can do is exist by themselves. Unless we're talking about lasers like we did earlier, we shock them with 5,000 volts. Okay, so group 18 is called the noble gases. Now here's where you may have learned some other names, but I want to talk to you as a chemist. We're not real worried about the names of groups. That's really on our priority list. That's way down here. But what happens is in groups 13, 14, 15, 16, and 17, okay, if you'll see this, I put 13, 14, 15, 16, 17, first element, okay? So group 13, chemists, we just call that the boron group. We call group 14 the carbon group, and group 15 the nitrogen group, and 16 the oxygen group, 17 the fluorine group. Even though we might talk about halides and things like that, or we might talk about, have all kinds of names for all these, as a chemist we just say, yes, it's a member of the nitrogen group, meaning that it's group 15. Okay, so once again, a lot of different things. You hear a lot of different uses, but as a chemist, we're not real worried about the name of the group. We're probably not even going to really refer too much to the alkali metals, other than the fact we know they have certain characteristics. Okay, group 1, the alkali metals are S1. Well, I'll tell you what I do know about the alkali metals is they're pretty explosive. If I make something up with those, something's going to happen. I got to watch out. If they're by themselves, I got a problem. And that's what it tells me when I say an alkali metal. Alkali, reactive. Latin, very reactive. Alkali metals, reactive. Whoa, sodium. If I have a piece of sodium, okay, it's so reactive that it reacts with air, reacts with water. I have to keep it in glycerin so that the air and the water can't be around it. Okay, maybe you've even years ago a kid in Chicago, famous deal, and they let every science teacher know this everywhere, high school, college. They cut this, and we used to use it in the lab. It was so cool. I would have loved to show you some of this pure sodium and some of this pure potassium. You cut it, and it's just so shiny. And then the air starts getting hold of it, starts fading out, starts turning black. It's super, but it's so shiny when you cut it. And then you put a drop of water on it, it explodes. It's amazing. So this kid in Chicago years ago, they did this in a lab, and he thought it was really cool. So I don't know, the teacher didn't do a very good job of watching the materials, and the kid goes in with a paper towel and he gets a big chunk of this sodium out of this glycerin. It's really super soft, and he gets it out of there and he puts it in his pocket. Oh, famous situation of how dangerous it was, and this kid probably is part of the reason why we don't have it in lives. That was so reactive that the electrons that are in there began to bond with things, and it began to eat away. It began to eat away his flesh and even down into his bone. And then he actually got the water from in that, and it exploded, and he had severe damage to his leg. So anytime I see the word alkali, I'm like, okay, that's dangerous. That's explosive. That's super reactive. That's everything in group 1. Okay, so. That's important. The transition metals, that's important. Noble gases, once again, group 13 through 17 is the first element. Now, let's go on to the next thing. Okay, so next thing. All right, now, which elements bond with which elements? Okay, now, this is if we're making a covalent bond. We're sharing electrons to make the octet rule. Okay, if we're sharing electrons to make the octet rule, then we want to do two things. We want, okay, now this is pretty critical. Okay, we want S2 and we want P6. We want S2 and we want P6. So the question is, okay, so group 1 bonds with what? And on your test, we're going to ask you all of these. Group 1 bonds with what? Well, what is group 1? Group 1 is S1. Oh, okay, what do I want? I want an S2. So what do I got to do to have another S1 here? Well, I can bond, group 1 bonds with itself. Oh, group 1 bonds with itself because an S1 and an S1 makes an S2. It's kind of like playing some kind of game, okay, where I can add them up, okay? So group 1 bonds with itself. That's why I see hydrogen, H2, lithium, and potassium. If these bond with themselves, they become stable. Because in their S2, and that's stable. S1, unstable. S2, extremely stable. Okay? So they bond with themselves, okay? Well, what else do they bond with? Well, let's take this out, okay? So in order to get an S2, I got to bond group 1 with itself, okay? Now I want to make a P6, right? Now I want to make a P6. Now here's the thing. An S electron can move up a level, but a P can't move down. So an S1 can move up, so I can use an S1 to make a P6. Oh, okay. So if I can combine, okay, so you're telling me that if I can combine that, okay, if I can combine an S1 with a P5, I can make a P6. Well, how do I know where that's at? Well, remember this is S1, S2. Now, remember transition metals we don't worry about? But this is P1, P2, P3, P4, P5. Cool, okay? So group 1 bonds with itself, and it bonds with 17. All right? Why? Because we want to make S2s, and we want to make P6s. So group 1, once again, to look back, it's an S1. What do I got to do to make it an S2? I can't pull the P's down. They don't go down, but the S's can go up. So S1 and S1 makes an S2. Oh, so group 1 bonds with itself. But to make a P6, I can move the S1 up and move it with a P5. P1, 2, 3, 4, 5. I can put it with group 17, and that's perfect. Oh, so what kind of things are we talking about making there? Well, let's see what's in group 1. I got hydrogen. Oh, and then there's all of the acids. Hydrochloric acid, hydrofluoric acid, hydrobromic acid. Great, great bonds because they make P6s. So I can also take sodium, okay? So I can make sodium, and combine it with chlorine. Sodium chloride, table salt, NaCl. I can make sodium bromide. I can make sodium iodide. I can take potassium. I can make potassium chloride, potassium fluoride, because they make good P6s. So now I have the octet rule where it's all healthy. Now, in the next video, we'll talk about the rest of the groups and what they bond with.